Invisibility has always been one of general public's imaginations. The recent scientific developments on transformation optics and metamaterials, and the way that journalism explains them to public has greatly enhanced such fascination, although a realization of a particle invisible clock is far from reach. But actually, research on one kind of invisible objects, non-radiating current sources, has quite a long history. As early as 1910, Paul Ehrenfest, in providing a stable model for atoms, has demonstrated that Maxwell equations allow for the existence of accelerating charge distributions which emit no radiation. In 1913, the need for non-radiating moving electrons is abandoned with the Bohr model of atom. However, the researchers on non-radiating sources didn't stop here and tried to explain the physics every time a new elementary particle was discovered. Although not successful in explaining elementary particles, those researches actually paved the ways for understanding physics of invisibilities later on, and also led to many researches on the inverse scattering problems since 1970s. Inverse problems is of great importance in all metrology methods trying to retrieve the parameters of an object from their far-field scattering or radiation. However, the existence of non-scattering or non-radiating parts makes the inverse problems of non-unique solutions. Consider a worm to be the non-radiating part of an object, like an apple. Since it is non-radiating, whether there is 0, 1, or infinite worms inside the apple, you won't be able to see it. The apple in your eye may just be an illusion, not a complete representation of the object. Anapole is one of such non-radiating current sources, formed by the destructive interference of a current dipole moment and a toroidal moment. This can happen, for instance, to the scattering electrical dipole moment of a high-index dielectric nanoparticle like silicon. However, under plane-wave illumination, many other modes like magnetic dipole, electric and magnetic quadrupole are excited at the same time, make it impossible to observe the non-radiating property. We proposed a configuration to make it possible to realize an ideal radiationless anapole. The excitation is a 4-pi configuration formed by two counter-propagating focused radially polarized beams. With exactly the same intensity distribution but of pi phase difference. Under such illumination, we show that a strong current inside the dielectric sphere at focus is induced, yet the illumination field outside the particle are not perturbed, as the particle under such illumination scatters no light at all, not even in the near field. We further prove that such particle excited by such beam but scatters no light doesn't violate the reciprocity theorem. If you are interested and want to know more about this research, please check our paper in Optica.